Welcome Sec 2 Express to algebraic fractions. We are going to learn algebraic fractions today. Let's recap back to what we have learned in primary school where we have a fraction plus a fraction. Without using a calculator, do you know how to add these two fractions? Now, if you remember clearly, we have to multiply by 7, multiply by 7, multiply by 2, multiply by 2. And why do we do that? It's because we want to make the denominator the same. So we want to do same denominator. Alright, now take note, we can only multiply to get the same denominator and not plus or minus. From here, we have the same denominator, which is 14. So I'm just going to write 14, which is the same denominator. 1 times 7 is 7, plus 3 times 2 is 6. If I simplify, this will give me 13 over 14, and I'm done. Now we are going to learn how to use algebra and join the fractions together. That means the question, instead of numbers, it will be in algebra. Let's take a look at worksheet 6C, work example number 1. How are we going to make this denominator the same? We have 2 over 3a plus 3 over 5a. Very simple to make the denominator the same. All I just need to do is to multiply by 5, multiply by 5, multiply by 3, multiply by 3, and now the same denominator. The common denominator will be 3a times 5, and 5a times 3 is 15a. The numerator 2 times 5 is 10, plus 3 times 3 is 9. If I simplify it, I'll get 19 over 15a, and I'm done. There's nothing else to simplify. Now, a common mistake that people like to use in this question is instead of multiplying by 5, they just did this. To make it the same denominator, they just add 2a, add 2a. Now, take note that you're not allowed to add to make the denominator the same. You can only multiply. So, no matter what, you have to multiply to make the denominator the same. If you have any problems, pause the video now and you can watch it later. You can watch it again to understand the concept. Let's take a look at part B. What if I have algebra in my denominator? How do I make them the same? In this case, a plus 1 and a. The trick is very simple. All I need to do is to multiply by a on the left side and multiply by a plus 1 on the right side. Once I do that, I will have the same denominator, which is a plus 1. Okay, I will name this step join. It's a 3-stage process to do algebraic fractions. Join, expand, simplify. To join, 1 times a gives me a plus 2 bracket a plus 1. I'm just joining it together because they have the same denominator. Second step, I'm going to do expand. I'm just going to expand the bracket at the top. 2 multiplied to a plus 1, and I get a plus 2a plus 2 over a plus 1. I do not need to expand the denominator. Now the last step, join, expand, simplify. I just simplify the numerator. A plus 2a is 3a plus 2 over a plus 1. And done. Okay, you cannot do anything like cancel off the a here like this because there is a plus over here. Okay, please take note, don't make these careless mistakes in the exams. If you are unsure about this question, you may pause the video now and take a look at my working to understand. Part C. Part C is a little bit different from Part B because if you notice, the denominator are expressions that you can factorize. So in this case, we must factorize first. So this is equals to 3 over, I take out 2 here, I get b minus 2c. Here I can take out 3, I'm left with b minus 2c. Okay, first step, factorize. From here, then you know what to multiply to make the denominator the same. Here I multiply by 3, multiply by 3. Here I multiply by 2, multiply by 2. Then I can do my join, expand, simplify. I can join them together, same denominator, which is 6 bracket b minus 2c. At the top is 9 plus 4. In this case, there's nothing to expand, so I can just simplify. Now, 9 plus 4 is 13, so it's 13 over 6b minus 2c. And we're done. There's nothing else to simplify. So that's part C. If you have any questions, you can text me. If not, then I'll move on to part D. Part D is a little bit different from parts A, B, and C. It's because if you notice, this is positive h, this is negative h, this is negative 2k, and this is positive 2k. Are the denominators the same? They are not the same, but they are very, very similar. So how do I make them the same? Let me teach you a little trick. That is to just multiply the denominator and the numerator by negative 1. You will see what I mean later. If you multiply by negative 1, the numerator will be negative 2h. The denominator will be negative h plus 2k. And on the right side, there is no change. Let's see. Minus h, minus h. Positive 2k, positive 2k. Are the denominator the same? They are the same. So now, I can join the fractions together. It doesn't matter if you write minus h plus 2k or 2k minus h. They are the same. And the numerator is just minus 2h minus 3k. And that's it. Finish. I'm done. Now, there's another way to do it. You might be asking, can I multiply by negative 1 on the right side instead? You sure can do that. Let me demonstrate to you. This is the question. Now I'm going to multiply by negative 1 here and multiply by negative 1 here. Then I'll get 2h over h minus 2k minus minus 3k over minus 2k plus h. Let's take a look at the denominator. Positive h, positive h. Negative 2k, negative 2k. Are the denominator the same? Yes, they are the same. So if they are the same, we can just join them together with the same denominator. It doesn't matter if you write negative 2k plus h or h minus 2k. So I'm just going to write h minus 2k. On the numerator, it will be 2h minus negative 3k. And I will get 2h plus 3k over h minus 2k. And I'm done. Then you must be wondering, but Cher, the answers to these two are different. No, they are actually the same. What do I mean by they are the same? See, if I were to multiply by negative 1, multiply by negative 1, they are equivalent fractions, right? For fractions, I can just multiply anything at the numerator and denominator and it will still be the same. And you see what I mean. Minus 2h minus 3k times minus 1 is 2h plus 3k. At the denominator, if I multiply by negative 1, I'll get minus 2k plus h. If you notice, isn't it the same now? But don't worry, you can either leave your answer as 2h plus 3k over minus 2k plus h, or the minus 2h minus 3k over 2k minus h. So in other words, it doesn't matter if you multiply the negative 1 to the left side or to the right side. We will still mark you correct. Alright, and the answer is exactly the same like what I proved to you here. Alright, after you're done with this, after you understand work example 1, I need you to do classwork 1, A, B, C, and D before proceeding to my next video to do work example number 2.